Hello, everyone. Thank you so much for joining us today. Today, we are having the session on building a resilient, highly available Postgres cluster with Patroni, pgBackRest, and LUKS. I have with me Semab Tariq as the speaker of this session. And Semab is going to walk you through all the process and steps that are required to create a production-ready cluster. So before I hand over the mic to Semab, let me go over a few housekeeping items. This webinar is being recorded and we will share the recording with you afterwards. If you have any questions, please feel free to share either the Q&A box or the webinar chat feature. And that's it from my end. Over to you, Samad.
Yeah, thank you, Annie. So, welcome everyone. I'm really excited to, of course, talk about high availability again, as this is one of my favorite topics as well. So today, instead of just theory, I want to walk you through to a real world success story where we helped our customer to set up a customized, high available Postgres cluster solution using all sort of open source tools that are available. So this was a highly customized solution, which was of course designed specifically to meet the unique requirements from our customer and their environment, of course. Before we actually get started, first thing first, and that is introduction. So yeah, of course, my name is Semab Tariq, and I work as a Postgres consultant at Stormatics. My initial journey with Postgres started back in 2018. This is when I joined second quadrant as automation engineer, and I used to work on Postgres community installers and CUDA installers at second quadrant. After then, I joined Enterprise DB in 2020. This is where I was again working with the Postgres community installers, releasing them and building and releasing all sort of builds. And currently, of course, working as Postgres consultant at Stormatics. And at Stormatics, we are keen to provide professional services for Postgres that include high availability, performance monitoring, backups, and recovery solutions as well. So yeah, this is sort of agenda about what we are going to cover in today's session. So first of all, we are going to understand what high availability is and what are the main types of highly available clusters. And then we are going to see what is the best highly available cluster for your businesses or mission critical applications. And then we are going to understand or see how we actually help our customers to implement a real world highly available solution with the help of Patroni, pgBackRest for backups and recovery, and LUKS for encryption for data, encryption of data at rest. And then finally, there will be a question and answer session as well. So first thing first, of course, let's first start with the basics of what is high availability or HA, you can say. In context of Postgres, HA actually means that keeping the database accessible at all the times, even during failures or planned maintenance activities. Well, it shouldn't matter if you are applying patches on your application side or database side, or you are restarting your database service, or you have faced or you are actually dealing with some sort of unexpected hardware issues and the service. Your application or database should be accessible to all the customers in all these sort of scenarios. And once you build this sort of application that is accessible throughout the year 24/7, then you can say this is a highly available cluster or solution for your needs. So the next question would be, how do we actually measure high availability for our systems? Well, most common way to actually measure the high availability for our system is actually we measure it using uptime percentage of our system. Like if like we can say our system is 99.9% of highly available, that actually means that we are saying that across throughout the year, our system will be 99.9% online throughout the years, of course. So in numbers, if I talk about if I am saying 99.9% of high availability, it actually refers to it actually means that our system can be down or we can face some sort of downtime of 8 plus hours throughout the years. And this is throughout the years, not per month. And if we say that our system is 99.99% of highly available throughout the year, that means we can expect 52 minutes of downtime per year. And similarly, if we say we have our system is 99.999% of highly available, in short, we call it 5 nines of high availability. That means that we can expect our system to have a downtime of at least around 5 minutes per year, which is again on a very low side if we have a 5 nines of high availability. Now, how do we actually track and improve the high availability for our system? We actually use two type of metrics, like we have mean time to failure and we have mean time to recovery. So let's try to understand these metrics in details. So mean time to failure actually tells you how long a system was operational before a downtime was hit, or something actually goes wrong with that system. So whereas mean time to recovery actually tells you how fast a system is recoverable from an issue. So usually we expect a higher, of course, mean time to failure and low mean time to recovery. And let's try to understand these two concepts from from example below. So let's say you have a system and that system was up for 180 days before hitting a downtime. So your mean time to failure would be two times per year. So if you multiply 180 to 2, you will get like 360 days. So that means that your system can have two downtimes per year. And let's say it took like 10 minutes to restore the system, and bring it back online. Now, if we want to calculate the high availability throughout the year, we will say that there are two downtimes per year, and the recovery time for each downtime is 10 minutes, right? So if we multiply the recovery time with the downtime number throughout the year, we will get the high availability ratio. So let's say 10 into 10 will 10 was your recovery time for one downtime, and 10 minutes was recovery time for one downtime. And if we have two downtimes, so we will multiply 10 into 2, that will be 20, right? So in that case, 20 minutes, we are expecting that our system can be down for 20 minutes throughout the year. So that is highly close to 99.999% of high availability. So you can say your system is close to 5 nines of high availability. So this is how you can actually track the high availability of your system. You can just get the mean time to failure and get the mean time to recovery, and then do some calculation. And this is how you can actually monitor or get the stats for how many minutes your system was down per year. And after getting all these sort of things, if your ratio is still 80%, 70%, or 60%, that means that you actually need to reconsider about high availability solutions, and you need to actually invest into high availability solutions so that you can go beyond 90%, or you can have 3 nines of high availability, 4 nines of, or 5 nines of high availability. So let's now try to see what high availability matters and what are the factors involved. So high availability can, of course, if our system is highly available, we can say we can have a from minimal to no data loss, right? So that is because all our primary node will be connected to standby nodes and replicating the data from primary to standby nodes in the real time. So that if something goes wrong with the primary node, we can always get back to standby node and promote it. So in that sort of scenarios, we can expect some minimal or no data loss as well. So if of course, if your system is highly available, it improves the user trust and the service reliability for your applications. And of course, it will be helpful for meeting SLAs or 24/7 operations throughout the year. So there are a couple of main components behind high availability. Here I have mentioned a couple of them, like your application. As I mentioned earlier, that our primary node will be replicating the data to standby nodes in the real time, so that a standby node is 100% ready to become a new primary if something goes wrong to our to older primary. And of course, this actually means that we can have auto failover where there is no need for human intervention, and everything can be handled automatically. Any failover can be handled automatically by the applications or the tools that we actually use to configure the high availability. Number three is load balancing, which is, of course, if you have a like 3-node cluster where you have one primary and 2 standby nodes, you perform all the writes on your your primary nodes, and all the read queries can goes to your standby nodes. This is how we can actually balance the load between throughout the cluster. And it can actually help us to improve the TPS, because if we so let's say if our primary is only responsible to handle the read and write operations, as compared to our primary is only performing the write operation. So in the second scenario, TPS will be much higher than the first case where primary is doing both of the operations. So of course, in highly available solutions, we can detect the issues quickly with some sort of monitoring tools or commands, and then we can respond as quickly as possible. So there are a couple of types of highly available clusters. So single node, I would not call it a highly available cluster, or of course cluster, because this is of course a single node. So by single node, I actually mean that you have only one Postgres server that is hosting Postgres, and you are performing all the reads and write on the server. If something goes wrong with that to the server, you will lose everything. You will lose or anything. You will lose every data that is, of course, available on that server. So single node will not give you high availability, and if node fails, everything is down. Everything is gone, and your application would be crashed. 2-node cluster, where one can be a primary and one can be a standby node. This is fine. We can call it some sort of highly available cluster, but it has a risk, and that risk is split brain scenario, where in split brain, what happens is, let's say if we have a one primary and one standby node, and a primary is replicating the data to standby node. So let's say if there is some network glitch between communication from primary to standby node, and standby cannot receive the data from primary, in that scenario, standby can think that okay, primary node is not unable to send me the data, so it might be offline, or it might go went offline. So in that case, standby can promote itself to a primary, whereas our original primary is still there, but it's just a network glitch that happens between primary to standby. So in that sort of scenario, now we have two primaries, right? One is older primary, and one the standby just promoted itself to a primary. We have two primary nodes. Now application is doing, if not managed well, it is actually it actually try to write on both nodes. So this is a huge, of course, issue where we can have a data loss. We we can have inconsistencies, anything. So two nodes is always not recommended because of a split brain scenario. Two nodes with one witness node. So this is one step ahead of the initial cluster that I just mentioned. So over here, we have two nodes, one primary and one standby node, but we add a one witness node as well. So a witness node is nothing but just a small node. It by the way, it do not have it did not contain some dot any data on that node. We just need a voting mechanism, you can say, which can help to determine, okay, which one is the primary node and which one is the standby node. And if there is some sort of network glitch happened in this case, when we have a witness node, then when it's very critical for witness node to not promote standby node. It can stop the promoting the standby node, and it can wait for fixing that network glitch. And this is how it can actually help to resolve the split brain type of scenario. So witness node, of course, can maintain quorum and will make automatic failover easier. And if we have a two node cluster with one witness node, one witness node, there is a chance of a single point of failure. So let's say we have a witness node which went down for some reason, right? So there could be a hardware issues, there could be a software issues as well. So if our witness node goes down, again, we are at a risk of split brain, because there is no one who is monitoring from outside the cluster. And now we are only left with one primary, one standby node. And if there is some network sort of glitch, then we cannot do anything without witness node. So of course, this is a single point of failure, which we have to understand. And while, of course, creating some sort of architecture for our applications. So another type of cluster would be three nodes with the three witness. I mean, you can have a two nodes with two witness nodes. So in this sort of scenarios, if your one witness node goes down, you still have another witness node that is actually monitoring the cluster. So that is of course helpful, but more typical way is to have three node cluster where one primary, two standby nodes, and three witness nodes. So in this sort of scenario, you can implement, you have automatically implemented high availability, you have automatically implemented auto failover. And now what you can do is you can now distribute your load as well. Now you have three witness nodes. If something goes wrong with one witness, two witness, you will have still one witness node that is monitoring your cluster and monitoring the health of your cluster, and can help to have voting process equally. So it is of course this is a I mean high level of higher availability or fault tolerance you can have with these three nodes and three witnesses. The next one, or the last, I must say, is multi-master architecture, which is so in multi-master architecture, this is more complex systems in Postgres or to implement as well. So in multi-master, what we do is we have like multiple nodes which can act as a primary and which can act as a primary node at the same time. So we can have three nodes, we can have 5, 7 nodes, and we can have 7 node cluster in region A and 7 node cluster in region B as well. So when I say region, maybe you can say one country to another country. So in this case, let's say if we have 3 node cluster of multi-master in somewhere in US or LA, and another cluster can be in Canada, some other city of Canada. That what will happen is users who lives in LA will be always performing reads or writes to their local cluster, whereas the users who are living in Canada will always be performing reads and writes on their local cluster. So that in this way we can reduce the latency, and because every node is performing writes, and there is a bidirectional application already set it up, so that data from US is traveling to Canada and Canada to US. So in this is mostly with this of course type of multi-master architecture, you can expect to have more five nines of high availability as well if you add geo redundancy in your cluster. So of course, uh, it's always critical to choose what is best for your business. So if over here I have mentioned a couple of recommendations about which type of cluster is best for your business. So let's say if you are running a non-critical or some development workload, you can go with single node. If you have if you want more manual failover than auto, then you can go with two nodes without witness, because without witness, automated failover will not be possible. There is, as I mentioned earlier, there is always a chance of split brain scenario. So two node with one witness node, it is a good choice for production setups. But keeping in mind with one witness, this is always a single point of failure. If something goes wrong with one witness, again, we can expect again split brain type of scenario. Three nodes with three witness. This is ideal set for a highly available production environment, and this actually provide us a fault tolerance on a higher level. Multi-master architecture only go with this sort of architecture if you understand this architecture very well, and you have some advanced cases like you have a business on in different regions of the world, then this can be a good fit for your business. So the architecture that I'm going to talk about here is two node, one witness that we implemented for our clients. And this is of course a customized solution. So I'll just go in bit details now. Now, with two nodes and one witness, when I say two nodes, I actually refer it as a two data nodes where Postgres actually installs. So by two nodes, I mean there are two data nodes where Patroni and Postgres are both configured on each node, each data node, and encryption at rest is placed. So there is a dedicated section for encryption at rest. I will go to some details about this later. But for now, you can just think of it as having some sort of encryption so that the data cannot be decrypted easily. So on both of your data nodes, we are configuring Patroni, and Postgres, of course, needs to be installed, and encryption needs to be in place for both our data nodes. So we can, over here, we can actually specify which mount points or directories needs to be encrypted only, not the entire disk. So what we are doing is we are only encrypting the logs directory and the data directory, which are more critical for Postgres. So we on both of the data directories, on both of the data nodes, we are only encrypting the logs and the data directory for the Postgres. One witness was also there. The purpose for one witness was to just monitor the cluster from outside, so that there is no chance for split brain. So on witness node, we have etcd installed, and for backups, we are again using the same witness node, and we have configured pgBackRest as well for on the same witness node. And of course, backups are encrypted because pgBackRest is pgBackRest by default provides some sort of backup encryptions algorithms as well. So this was our high level of architecture. Like we have two nodes, one witness, and the Patroni and Postgres was installed on data nodes, and witness node. There is etcd and pgBackRest were installed on that node. So how to actually configure the Patroni? So on both data nodes, we actually have to first install Postgres in order to make them data nodes. So once, this you can just use this community link to install the Postgres on the data nodes. And once Postgres is installed, the next step is to install the Patroni on the data nodes. So if you have two data nodes, you are going to perform install Postgres on and Patroni on both of the nodes. So if you have more than two nodes, like 3, 4, or 5, you will have to install Postgres and Patroni on all the data nodes inside your cluster. So installing Postgres is pretty straightforward. You can just refer to that link. The next step would be to install Patroni. So in order to install Patroni, what you can do is you can create a dedicated operating system user which can be used to handle Patroni. Here I have created Postgres user, and this is how we are actually installing Patroni with the Python package. What we are doing is we are just enabling the Python virtual environment, and then we are activating that Python virtual environment, and then installing the Patroni package with the pip command, a simple pip command. So when you execute this command, Patroni will be installed on your system. And then, as I mentioned, that data and log directory will be encrypted. So we will have to specify, create the data directory, and we have to create the log directory as well. I'm not sure why it is missing over here, but you have to create the log directory as well in order to actually use that with Patroni. So before initializing the Patroni, your data directory and log directory needs to be present there. And they should be encrypted as well. So if you want encryption, you can just skip this section and go to the encryption section first, perform the encryption, and then refer to this Patroni section. So just to recap, we created a system user, we installed the Patroni, we created the data directory, and we create the log directory and set the proper permissions for data and logs directory. The next step would be install etcd. So on data nodes, we have installed Patroni. Now we are going to move to etcd node, where we are going to install etcd. Of course, first step is just to install etcd, because I have tested this setup on, I think it was Ubuntu 2404. Default Patroni etcd packages were not available in default apt repositories. So I have to use GitHub to clone the repository, and then I think it was I get that binaries. I got the etcd binaries from GitHub, so you can do the same here. So the next step would be to install etcd. You can just go to this URL, download the binaries of etcd, latest binaries of etcd, untar the package, and then what we will have to do is we have to generate the TLS certificates so that we can perform secure communication between both from etcd to Patroni and from Patroni to etcd. So for production type environment, I would recommend to use HTTPS instead of simple HTTP protocol, because this is not a secure one. So what you will have to do, you will have to create a private key. Of course, you can use or refer to these commands that I just shared, where I'm creating the private key, a private server key, and then creating the certificates and allowing the and self-signing these certificates. And finally, once these certificates are ready, you will have to manually copy these certificates from etcd node to the Patroni nodes, so that Patroni can also use these certificates to communicate with etcd node. So once you created these sort of certificates, the next step would be to actually start the etcd node. So this is how you can simply start the etcd node. You can do that manually, but you can also create the service for etcd as well. What you can do is you can just create a service file inside your service manager, and then use systemctl start etcd command simply to actually start and stop the service from service manager, whatever you are actually using. So this is pretty straightforward command to actually start the etcd on your 2380 port. So on your etcd node, 2380 port will be assigned to etcd, and etcd will be listening to this port. And then, of course, you are mentioning all the certificates that you created to perform a secure HTTPS communication over the network. So once your etcd node is configured and certificates are ready, the next step would be to test the connection from data nodes to etcd node. So on your data nodes, you can go to your data nodes one by one and just execute this simple query or command where we are actually performing. As I mentioned earlier, that you have, after generating the certificates on etcd node, you will have to copy these certificates to Patroni nodes as well. So that Patroni node can also be used to perform HTTPS secure communication with etcd. Now, we are assuming that you have already copied the certificates like client.crt and you have copied the key as well. So after that, you can just perform this curl command and give the IP address for your etcd node and get the proper port for the etcd and just mention the health. And if it returns as you can see, I am using https instead of http. So if it returns success, then it means that your etcd node is ready, your data node is ready to perform secure communication from both sides. You can actually, of course, in that case, your both nodes are ready. Then you can, of course, go ahead with the next steps. So over here, I would like to mention one thing that we should always keep our keys secure. If we are keeping the keys like client.key, as I have here, if we are keeping our keys on our host system, we should make sure that permissions are well defined and security groups are well defined. No one else other than us can access this. And it's better to use some sort of vault for storing these sort of keys. So maybe you can use HashiCorp Vault in order to store these queries, and then once whenever you are required, you can retrieve these keys from the vault as well. So of course, there are a couple of things that we need to make sure, and we need to consider a few things before creating the certificates. Like one thing is I already mentioned, use Vault for storing the keys, use proper permissions for the keys if you are storing them locally. Uh, Also mention the rotation period for your keys. So let's say over here with this, like if you see this days with this days switch, I'm mentioning 365, which actually means that I'm creating this key or certificate for 1 year. After 1 year, it will be expired. So it's highly recommended to actually use the period that is required from your organization. Like you cannot go with the 10 years or 15 years or 20 years of validity for a certificate, because it will create some loopholes in your systems, and it always recommended to use a short period of time to create the certificates. So once, just to recap, as for now, we have created Patroni, we have configured Postgres and Patroni. We have installed Patroni on our data nodes, and we have configured and installed etcd on our etcd node, of course. Now, the next step would be to set up patroni.yaml file. So there is a patroni.yaml file we will have to create on our data nodes, which will have all the proper settings that can be used by Patroni itself. So I'll just quickly move to my terminal just to showcase you that patroni.yaml file. So I have that patroni.yaml file here. This is just a skeleton of a simple patroni.yaml file. So I will just go through to it very quickly. So first of all, you will have to mention because this is a Patroni file, so this needs to be present on both nodes. So over here, you can just specify data node 1, data node 2, data node 3, how many, it doesn't matter how many nodes you have, you can just mention here. And then you have to mention the IP address for your Patroni node over here, or data node, I must say. Then you will have to, for secure communication with etcd, the certificate that you generated on etcd node needs to be copied to data nodes and then specify the path over here on data nodes, like these sort of things. Then we will have to specify some parameters for DCS or our voting system, how it will be effective to our cluster. And then finally, we will have to specify or allow a couple of IPs that we want to connect to our cluster. And then what we can do is over here, you have to mention the particular IP address for your node. So let's say if you are creating this file on your data node 1, you will have to mention that IP of data node 1 over here, so that Patroni can be listen to Postgres. And then path to data directory, wherever you want to create the data directory on your system, you will have to specify there. Patroni will create the data directory itself. You don't have to create the data directory before running the Patroni. Password needs to be specified for whatever user you are going to use for application. So you can specify the passwords here. You can specify the password file path here. So these are just dummy values that I replaced for, of course, some security reasons. So this is your main patroni.yaml file that you need to create on all of your data nodes across the cluster. So quickly going back to the cluster. So once you have your patroni.yaml file ready on your data nodes, you can just simply start your Patroni service with the systemctl start Patroni, simple commands like that. And Patroni will be started on that server. After Patroni starts, the next step is to verify the cluster. So how you can actually verify the cluster? So there is a Patroni or a Patroni CTL utility available inside Patroni Patroni binaries. You can use that patroni.ctl, specify the patroni.yaml path, and just perform the list. Give the list as an argument. So what it will do, it will just retrieve the information about. Before performing that, you will have to start the Patroni on all the nodes across the cluster. So after you perform this list operation, it will specify the data nodes, their IP addresses, their role. In my case, my data node 1 is the leader, data node 2 is the replica node, which is receiving the data from the leader, and of course its status is streaming application. The next, it is showing TL timeline, which is showing how many times this cluster undergoes from a downtime, or there was a downtime inside the cluster. So it specified 2 times there was a downtime inside the cluster, and there is no replication lag from replica to the leader. The next step would be to connect with the cluster. So you can simply use PSQL -h leader IP address, and then Patroni port -d -u to actually connect with the Patroni cluster. But make sure that the client that you are using is actually allowed inside pghba-conf. So you will have to first allow that client, and then only this client can be able to connect to the Patroni cluster. So the next step would be to, maybe you can try to ingest some data to your leader and test that application. You can perform the failover. If you want more details, I have a dedicated blog written on the same setup. You can refer to that blog, but I would suggest that use HTTPS for secure communication instead of HTTP that was used in my blog. So always use a secure method of communications. So all right, now we can actually once we created, so as you see, there is no proxy was configured. We can configure HA proxy for load balancing or for connection rerouting, but at the moment there was no connection, there was no connection routing from proxy. So how we can actually manage that is, from one, we can use application to actually manage all the routes. So that how we can actually do that, our application needs to be 100% aware that who is the current leader. so that it can send all the writes to that leader. So if there is a failover, our application needs to be know that there was a failover. Now the current primary was changed. Now I need to reroute that traffic to some other primary. So our application needs to be aware of the first thing, the first case is our application needs to be aware, and the second is of course more suitable and more easier way is to use some sort of proxy to manage your connection or routing inside, of course, real world or mission critical applications. Once you are done with Patroni cluster, the next step would be to create a backup solution for your cluster. So for backup, we choose pgBackRest. Now, the reason being, it provides a lot of benefits from encryption to point-in-time recovery, from word archiving to you can encrypt your backups, and there is you can actually store your backups directly from your local machine to S3 storage as well. You can actually archive your walls to S3 storage as well from directly from your backup server to cloud storage. So in order to, of course, set up the backup solution, we choose etcd node. And first of all, we have to install the pgBackRest on etcd node. This is a very simple command to install the pgBackRest. And then we have to create a pgBackRest .conf file on our backup server, which is responsible for taking the backup. So again, I will go to my terminal and just to show you the pgBackRest file, how it looks like. So this is how a simple pgBackRest.conf file will look like. So first of all, you will have to mention the repo path. So this is nothing but a simple location of your local server where you are going to place the backup. So if this is a etcd node, this is simply some sort of local path where you are going to store the backups. Retention policy is type is time and set to 7 days. So that means that our backups will be expired or deleted automatically after 7 days. We have to mention which user is responsible to taking the backups. I said Postgres. Then you will have to specify where you want to store the logs of pgBackRest. Here you can mention your particular directory, and this is an important step or important section where you will have to create a name of your cluster, or you can say stanza name. I will get back to it later. So over here, first, as we have two servers, two data nodes, so we will have to provide two information or two sections, separate sections for our data nodes. For first section for first data node and second section for second data node. Over here, you will have to provide the first IP, first data node IP, and then second data node IP, and then data directory path for first data node and data directory path for second data node. So this is how you can actually create the, after installing pgBackRest on backup server, you have to create that file on backup server. And then the next step would be to actually configure passwordless access from data nodes to backup node, so that backup node can actually interact with our data nodes in passwordless manner and perform the backups. You can create your key and copy the public key over to your backup server. The next step would be after you configured the SSH access, then you have to install pgBackRest on data nodes as well, because this is required. On data nodes, we use some sort of pgBackRest utilities to actually perform the backups. So after installing the pgBackRest on data node as well, you will have to update a property, a Postgres.conf property, which is like archive command. So because this is a Patroni managed cluster, so you cannot directly update Postgres.conf file, which is not recommended. So we are going to use this simple command by Patroni, which is Patroni CTL, providing the configuration file name and edit dash config. So it will open up another separate window or terminal, you can say. And then over here, you can specify archive command to pgBackRest. And the stanza name will be the same that you mentioned inside your Patroni, pgBackRest configuration file. and archive push. Now, what this will do, whenever a val is generated on our data nodes, it will be pushed to backup node so that we are saving vals for performing point in time recovery. So after doing that, we have to create a stanza. Stanza is nothing but a local directory which is responsible to store the backup on backup server. So we will have to create that, and then we can, of course, take a first full backup from our backup server or etcd node. In our case, that is like a simple command where we have to give the stanza name. We have to tell the type for backup we are creating. It is full, and then simple back command which will be taking care of having a backup. So a restore process is pretty straightforward as well. What we have to once our backup is healthy and configured, what we have to do for a restore process is spin up a new VM to restore, and we have to install the pgBackRest on new VM where we want to restore the backup. We will have to install Postgres, of course, on that server. Then we have to create the pgBackRest conf file again on that server. The basic skeleton for that file would be like that. On the restore server, you will just have to mention the information about where is the what is the IP address for your backup server, and where is the backup actually stored, so that if we are performing point in time recovery, our new VM can be able to connect to our backup node and retrieve all the vals from that backup node on the fly. And then we have to specify where we want to create the new data directory on our new restored VM. So after that, we will have to update one again, simple property name restore command. Now, because this is a new VM, this is not a Patroni cluster, we can simply go to postgres.conf file and edit it manually and mention this pgBackRest stanza name archive get command, so that this will be only triggered when there is a val file required to perform a restore, and Postgres needs that val file, and that val file needs to be fetched from the backup server. So in that case, this will be required. And of course, you can then use simple restore command from your restore server to actually restore the backup. And of course, pgBackRest provide you point in time recovery support. So this is how you can actually specify point in time recovery with the target switch over here. And then once you have data directly on your new VM, you can just use pgctl command to actually start the VM. So I think I have already mentioned this sort of thing why we choose pgBackRest. So pgBackRest, of course, perform supports point in time recovery with val archiving, backup. We can actually encrypt our backups. We can actually integrate our backup server with S3 or on AWS, so that instead of taking the local backup copy, we can directly push these backup to the S3, so that if backup server goes down, we don't lose any further backups. Our backups will always be available on S3 storage. And of course, if we configure val archiving as well, so all the vals will automatically be thrown to S3 storage as well. pgBackRest also supports compression algorithms as well, so that you can actually compress your backups. And let's say if you have only one backup node which is responsible to taking the backups, in that case, this is again a single point of failure. If something goes wrong with your backup server, there will be no further backups, or you can lose your backups if you are storing them locally instead of S3 storage or cloud storage. So again, this is a single point of failure. So in that case, what you will have to do, you will have to go through to all the configurations that we initially discussed, and creating a new VM, configuring pgBackRest, and then uh, configuring pgBackRest, and then performing backups and use that new server in future. All right. So to our encryption section, for encryption, we can actually use a simple Linux utility, which is Linux Unified Key Setup. Short form would be LUKS. What it does is it can actually help us encrypt the whole. It can actually encrypt the whole drive, a partition of our drive, or it can even encrypt the LVM of our drive. So if we don't want, so let's say if we have a total drive of 1000 GBs or 1 terabytes, and we only want that our 100 GB partition, which is storing the data directory or which is storing log information, only this partition needs to be encrypted. So this can be easily done with the LUKS. And of course, this will perform encryption for data at rest. Now, what data at rest encryption means? Let's say uh, our systems, we have encrypted our volume or drive, whatever you have, and the system is powered off. In that case, your data will be encrypted form. So if someone physically steals your stolen your drive from your machine and try to plug into some other system, it will be encrypted, and he or she won't be able to access that system until they decrypt that data. So data at rest only encryption of data at rest only benefit us in case of physically if someone physically stole the drive from our system. On the other hand, if my drive is already encrypted, but I'm using that drive, it is decrypted on the fly, and I'm performing some writes on the drive. In that case, if someone to access for our from our system, in that case, they will be able to access that data inside that drive. So this will not be protected in this case if they are already encrypted and using operating system is using that drive. So here are a couple of other benefits of using LUKS for encryption. I will just go to some details how to actually encrypt that. So first of all, we have to understand which drive needs to be encrypted. So we can actually use lsblk command to actually view the our file system or our drive information. And over here, you can see I have a drive of like 1 TB. And if I have a data drive and separate log LVM, not the drive, but LVM, logical volumes. Logical volume is of size of 900 GBs, and log volume is of size of 100 GBs. So we can, of course, encrypt only these tools. So how we can actually encrypt these tools? We can just simply run this. Of course, first of all, we have to see if crypt setup is installed on system. It is pretty straightforward to install. Only you can use yum or apt get install crypt setup. And once this is installed, you can just run this particular command sudo crypt setup LUKS format, and then give the drive name that you want to encrypt. In my case, I want to encrypt data and logs. So I will run this command 2 times, one for data and one for logs. And each time I run this command, it will ask me a passphrase. So we'll have to provide the password to actually, which will be used to decrypt that drive. And after that, and it will format everything inside your drive. If there is some data available inside your drive, it will be formatted. So make sure that there is no important data available inside your drive before running this command. So this is how you can encrypt, and then how you can actually decrypt that. You just have to specify crypt setup open, give the drive name that you want to decrypt, and then give the new name for decrypting for the drive that will be decrypting. So let's say I encrypted my data drive, and the data drive is encrypted, but I wanted that once this is decrypted, it should create a new drive by the name of decrypted data volume. So this is how I can do that. I can specify another name for new drive. So once I run this command, a new volume will be get created on my system, and it will be named as a decrypted data volume or decrypted log volume. So to decrypt both data and logs, we have to run this command 2 times. And then once our decrypted drive is ready, we can actually uh, then we can actually decrypt and mount these points as well. So you can use your keys for encryption and decryption as well. So this straightforward. I think we are short on our time, so I'll just skip this one. So this was it from my side. And if you have any questions, you may ask now. Yeah.
Thank you so much, Sama. So we do have a few questions. I will get started with the first one. I would be interested in your opinion on using Docker versus Docker Swarm versus Kubernetes for running a database. Specifically, do you think plain Docker or Swarm is suitable for deploying a HA Postgres cluster with Patroni? Because running DBs and containers seems to be one of those things that really splits opinion.
All right. So of course we can use Docker, Kubernetes, or any other platform that was mentioned inside that question. The only thing we have to understand is like what is our business need, and what sort of architecture do we need, and how complex it is to actually create or manage once this is deployed. So this is not always one size fit for all. There are pros and cons as well. So we will have to 100% be sure that what is our operation need, and what sort of cluster depth we need. So I would just say, if we need if we are running a small business, just go with some sort of VM based approach. If you can if you are running some fintech company, then maybe you can use Kubernetes as well. So it really depends again on your actual business needs.
All right, thank you. The next question is, how can you make a major upgrade in Patroni cluster, both Patroni itself and Postgres, and maybe etcd itself as well?
That's a nice question. Okay, so uh, there is a technique by the name of rolling upgrades. We can actually use rolling upgrades in order to upgrade our cluster. So what we do is, in rolling upgrades, we generally upgrade our. Let's say we have one primary, two standby nodes, and what rolling upgrade would do is, we go towards standby one. We just perform upgrade on that node. First of all, we have to detach that node from the cluster. So we will just upgrade that node and then reattach to the cluster. Then we go to standby two node, upgrade that node, and then reattach to the cluster. Then we have to go to primary, make it standby, or spin up a new instance, and upgrade that instance, and then reattach to the cluster. So this is how you can actually do one by one upgrades on entire cluster, and it will be and with rolling upgrades, there is a highly less chance of downtimes for your applications.
Fun fact, folks, we actually have a whole webinar on rolling upgrades by Semab, so you can definitely check that out. Moving on to the next question. So this was on slide 18. They asked what will automatically update the PostgreSQL.conf file while editing it with Patroni CTL?
Okay. It was what number was that? I'm not sure where is the numbering of the slide. Hold on. I think he was talking about this Patroni CTL edit conf, right? Okay. So this parameter is actually this was for pgBackRest. Like so what this parameter is actually doing is whenever a wall is generated on our data node, it Postgres is going to execute whatever written inside this parameter. So it will just execute this command pgBackRest stanza name and archive push. It will just pick that wall file and push that to the backup node to of course save the wall file. So whenever a wall is generated, it will just push to the backup server.
Okay, so is it possible for a cluster to have different major PostgreSQL versions during rolling upgrades process?
Different major versions. So it depends. Like if your cluster is set up using logical replication, then yes, you can of course have different versions. But if it is a simple streaming replication with base backup, I don't think then it will allow you different versions. So it actually matters how you actually.
No worries. We are having a different kind of remote work today, so
Sorry about
like that, folks. It's all right. So the last question, of course, is second last is should we create a new Patroni cluster with new PostgreSQL version or start physical replication to a new cluster?
Okay. So if you are creating a new cluster, I would suggest to go with the logical replication. That will be more benefit and this with I can't understand why you want to go with the streaming replication, because what rolling upgrade does is why we do rolling upgrades, we have to upgrade the versions, right? So if you have to upgrade the versions, then it's better to use logical replication to stream the data to some other cluster.
Okay. And our last question is, what is Stanza? Is it some kind of repository?
You can say that it is a repository. So if I have to be very technical, Stanza is available inside your backup node. Whatever backup node it is, it is like a local directory on your backup node where you are going to just store your backups. So you can say repository, you can say Stanza, both are the same words. It's just a local path on your backup server where you are going to store the backups, or of course wall files as well.
All right. I think that is the end of all the questions. If you have any more questions, folks, please feel free to reach out to us either directly to Semab or at info@stormatics.tech. Thank you so much for your time. And of course, we'll see you next week with a fireside chat in which Mark Linster, the former CTO of EDB, is going to talk about workloads and when they are to be used with Postgres and when you need to look for another option. Thank you so much for today and bye-bye.